Hello everyone, in this video we will explore topic 8.12 what's the method revolving around the other axis. Alright, so remember we learned before we have the volume formula. When you revolve the regions about the horizontal axis, it's going to be V equals pi integral from A to B, the bigger radius square minus the smaller radius square ds, right? So when it's come to the horizontal axis, it's going to be S value, right? Similarly, the vertical axis of revolution, the volume is given by pi times the integral from C to D of bigger radius square minus the smaller radius square, and in terms of y, right? Now, remember the Watson method, you always have a hole in the middle, right? Now let's take a look at the first example. What's the method using other axis revolution number 1? Alright, find the volume of the solid formed by revolving the regions bounded by the graphs y equals s squared plus 1, which is the plus 1 right here. Y equals 0, which is the x-axis right here. S equals 0, which is the y-axis right here. And s equals 1, which is this guy right here. About the line s equals negative 1. Alright, so s equals negative 1 is the axis of revolution. Alright, so I call this one A, O, V. Alright, shade the regions being revolved, draw the axis of revolution, and draw the representative rectangles for capital R and the little r, right? So the shaded region should be this guy right here. Now s equals negative 1 is the axis of revolution, so it's going to be right here. Now when you revolve this one about this line, it's going to be something like this. Alright, so I need to separate this guy into two regions, right? The bottom is going to be from here to here, and the top should be from here to here. Alright. Now the bigger circle for the radius is going to be the bottom one right here. And the smaller circle is going to be right here. Now we need to get the rectangles right here. So the bigger rectangles is going to be from here to here. And the smaller rectangle is going to be from here to here. Right? Volume of the solids is V1 plus V2, right? V1 is the yellow ones right here. V2 is the green one right here, right? Now you have V1 equals pi, the integral form. Now you need to be careful when it comes to the vertical axis of revolution. Your volume should be in terms of y. So the upper bound and lower bound should be right here. 1, and this one should be 0, right? So it could be the integral from 0 to 1, right? Bigger radius in terms of y squared minus the smaller radius in terms of y altogether square dy, right? Keep that in mind. Now the bigger radius is s right subtract s left, right? S right is right here. S left is right here, right? So it's going to be pi, the integral from 0 to 1. S right is 1. S left is negative 1, right? So it could be 1 minus negative 1 altogether square, right? Subtract the little r right here. S right is the y-axis right here, which is s equals 0, right? So it could be 0 minus s left is right here, negative 1, right? So subtract negative 1 altogether square dy, right? Then it's going to be pi, the integral from 0 to 1. It's going to be 4 minus 1 altogether dy, right? So it's going to be pi times the integral from 0 to 1 of 3 dy. 3 pi times y evaluated from 0 to 1. So the answer is 3 pi. Right now, v2 equals pi times the integral from here 1 to this guy right here. Alright, so we need to find the intersection right here between the parabola y equals s squared plus 1 and the vertical line s equals 1 right here, right? So I'm going to put this one on the side note. So I have the system of equation y equals s squared plus 1, s equals 1, right? Substitute 1 for s, so I have y equals 2, right? So v2 equals pi times the integral from 1 to 2, right? Now the bigger radius is still this guy right here, right? So which is s right subtract s left, right? So it's gonna be 1 subtract negative 1 altogether square minus the smaller radius is depending on the graph right here, right? Now remember that this one must be in terms of y, right? Because the representative rectangles perpendicular to the vertical axis, right? So you need to rewrite this one in terms of y, right? So I have y equals s squared plus 1, then s squared equals y minus 1, right? Take square root both sides, so s equals plus and minus square root of y minus 1, right? Now you look at this one right here, it's gonna be on the right of the y-axis, so it should be positive. So you need to eliminate the negative side right here, right? So it's gonna be square root of y minus 1 minus, right? This one is the right. The left hand side is right here. Alright, so subtract negative 1 square dy, right? Now I'm going to simplify this one, so it's going to be pi, the integral from 1 to 2 of 4 minus square root of y minus 1 plus 1 altogether square dy, right? Now to find the answer for this one, you can calculate this one by hand, or you can use a calculator. So I'm going to print up the calculator to calculate this one faster. Alright, so I'm going to add calculator and I'm going to press menu, calculus, integral from 1 to 2. Don't forget to multiply by pi, right? So I put pi in the front. And I hit enter. The answer 7 pi over 6, right? Alright, so the final answer is 3 pi plus 7 pi over 6. Alright, so it could be 25 pi over 6. Now let's move on to example number 2. We're gonna revolve these regions about the line y equals negative 2. Alright, so y equals negative 2 is gonna be right here. Alright, so here's the complete solid after the revolution, right? So the axis of revolution is y equals negative 2, right? And this is horizontal axis, right? So if this horizontal axis, the volume should be in terms of s, right? And the representative rectangles must be perpendicular to the axis of revolution, right? So the bigger radius is right here, right? And the smaller radius is right here, right? In this situation, you don't need to split this one into two integrals, right? So the volume should be pi. The integral from here to here, which means from 0 to 1 of the bigger radius, right? The bigger radius depending on this guy right here, right? Subtract this guy right here, right? But this guy right here is going to be y equals s squared plus 1, right? So you have s squared plus 1. Subtract y equals -2, right? Subtract -2 all together squared minus the smaller radius, which is this one, y equals 0, right? Remember, y top subtract y bottom when it comes to the horizontal axis of revolution, right? S right subtract S left when it comes to the vertical axis of revolution, right? So this guy turns out to be 0 minus -2 altogether square ds, right? Now I'm going to simplify this one. It turns out to be pi times the interval from 0 to 1 s squared plus 3 altogether square minus 4, right? ds. Now I'm going to use the complete square formula to expand this one. So it could be pi times the interval from 0 to 1 s power 4 plus 6s squared plus 9. Subtract 4 is going to be 5, right? ds. Now remember, the complete square formula is going to be a plus b altogether square. It's going to be a square plus 2ab plus b square, right? Now take anti-derivative of this one. It's going to be pi times 1/5 s power 5, right? Plus 2s cubed, right? Plus 5s evaluated from 0 to 1, right? So it's going to be 1/5 plus 2 plus 5 times pi, right? Substitute 0 for s, is going to be 0. Now I'm going to simplify this one. It turns out to be 36 over 5 pi. This one is the final answer. Now let's move on to example number 3. Now in this situation, we're going to revolve the regions about the line s equals 2. Alright, so this one is similar to the first example, right? The first example, we're going to revolve about the line s equals -1, right? Now we need to revolve this one about s equals 2. So it could be right here. Alright, so you're going to sketch the solid. It's going to be something like this. Now again, we need to split this solid into two regions, right? The first one is from 0 to 1, right here, right? The second one is from 1 to 2, right? So I call this one is V2. This one is V1, right? Similar to example number 1, right? So I have V equals V1 plus V2, right? Now, V1 is pi times the interval from 0 to 1, right? S right subtract s left, right? Square minus s right subtract s left square dy, right? So it's going to be pi times the interval from 0 to 1. Now remember, the axis of revolution is s equals 2 right here, right? So the bigger radius is from here to here, right? So it's going to be 2 minus 0 altogether square, right? Now the smaller radius is from here to here, right? So it's going to be 2 minus 1 all together square dy, right? And it's going to be pi times the interval from 0 to 1, 2 square equals 4. 4 minus 1 is going to be 3, right? So it could be 3 dy. And it's going to be 3 pi times y evaluated from 0 to 1. It's going to be 3 pi, right? So V1 equals 3 pi. Now V2 is the green one right here. Now, in this situation, the bigger radius is dependent on the graph right here, right? This one is y equal s squared plus 1. In the example number 1, we rewrite this one in terms of y. It turns out to be square root of y minus 1, right? S equals. Now, the bigger radius is the radius of the bigger circle. It's going to be right here, right? It's dependent on the graph of this one right here, right? And the smaller radius is right here. Alright, so you have pi times the integral form. In this situation should be 1 to 2, right? The bigger radius is the distance from here to here, right? So it's going to be 2 minus square root of y minus 1 all together square. Subtract the smaller radius, it's going to be this guy right here. 2 minus 1 square dy, right? And you're going to simplify this one. It turns out to be pi the integral from 1 to 2 of 2 minus square root of y minus 1 all together square minus 1. Now you're going to bring up the calculator. Enter the expression right here and then hit enter. The answer is 5 pi over 6. Right? And then V equals V1 plus V2. V1 is 3 pi, right? And V2 is 5 pi over 6, right? So the answer is 23 pi over 6, right? Now let's move on to example number 4. Find the volume of the solid formed by revolving the region bounded by the graphs y equals s squared, y equals s power 5 about the line y equals 0. So y equals 0, which means the x-axis. So this guy becomes the axis of revolution, right? Shade the region being revolved. Draw the axis of revolution and draw the representative rectangles for capital R and little r, right? So y equals s squared, it could be something like this. S equals 1, y equals 1. S equals 2, y equals 4, right? So it could be something like this. Now, y equals s power 5, it could be something like this. Then, the shaded region should be this guy right here. Now, we need to revolve this one about the x-axis, right? So, it turns out to be something like this. Alright, so the smaller radius is the distance from here to here, right? This one is the representative rectangles, little r, right? And the bigger radius is going to be from here to here, right? So volume is pi times the integral from 0 to 1 right here. How do we get 1? Because the intersection between these two graphs right here should be 1, right? We can solve a system of two equations. Y equals s squared and y equals s power 5, right? So it turns out to be s squared equals s to the 5th, right? And subtract s to the 5th both sides, so have s squared minus s to the 5th equals 0. Factor s squared out. 1 minus s cubed equals 0, right? So s squared equals 0 and 1 minus s cubed equals 0. Now you solve this one, s equals 0 and this one s equals 1. That's why you get 0 and 1 right here, right? So the volume is pi times the interval from 0 to 1, right? The biggest radius in terms of s subtract the smaller radius in terms of s squared, right? ds. So it's going to be pi times the interval from 0 to 1. The bigger one is the blue one right here, right? So it's the difference between y equals s squared and the x-axis, which means y equals 0, right? So you have s squared minus 0 all together square. Subtract. The smaller one is the black one right here, which is y equals s power 5 and the x-axis, right? So it's going to be s power 5 subtract 0 all together square ds, right? Then it turns out to be pi times the interval from 0 to 1 s power 4 minus s power 10, right? ds. Now take antiderivative of this one is going to be pi times 1/5 s power 5 minus 1/11 s power 11. Evaluated from 0 to 1. So it turns out to be pi times 1/5 minus 1/11, right? And it turns out to be 6 over 55 pi, right? Now let's move on to example number 5. We need to find the volume of the solids formed by revolving the regions bounded by the graphs y equals square root of s, right? So s equals 0, y equals 0. It's going to be right here. S equals 1, y equals 1, right? And s equals 4, y equals 2. So it could be something like this. Alright, y equals 0, which is the x-axis, right? Y equals 0 right here. And s equals 3, so it could be right here. Right? So the region should be this guy. Now, when the y-axis is the axis of revolution, the solid should be something like this. Alright, so the bigger radius is right here. And the smaller radius is right here. Right? Now, you need to rewrite this one in terms of y because you revolve these regions about the vertical axis, right? This guy is y equals square root of s, right? You write over here y equals square root of s, right? So square both sides, so it could be s equals y squared, right? And this one right here, s equals 3, right? So you need to find the intersection right here. In order to find the intersection right here, you need to solve a system of equation between this guy right here and this guy right here, right? So I have the system y equals square root of s and s equals 3, right? Substitute 3 for s into the first equation. I have y equals square root of 3, right? So the volume is pi times the interval from 0 to this guy right here, root 3, right? Of bigger radius, which is the pink one right here, right? It's going to be s right subtract s left. S right is s equals 3. S left, which means s equals 0 right here. It's going to be right here, right? So I have 3 subtract 0 altogether square minus the smaller radius is going to be right here, right? S right depending on the graph right here, right? It's going to be right here. Y square minus s left, which is s equals 0, right? dy. Now I'm going to simplify this one. It's going to be pi times the integral from 0 to root 3 9 subtract y power of 4 dy, right? Then it's going to be pi times 9y minus 1/5 y to the 5th evaluated from 0 to root 3, right? So substitute root 3 for y, it turns out to be pi times 9 root 3 minus 1 over 5 root 3 altogether power of 5. Substitute 0 for y, it's going to be 0, right? Now I'm going to simplify this one further, so it turns out to be pi times 9 root 3 minus 9 root 3 over 5, right? And simplify this one further, it turns out to be 36 root 3 pi over 5. This one is the final answer, right? Now let's move on to question B. The axis of revolution is s equals 6, right? Now this is a complete solid, right? So the bigger radius is depending on the graph right here. It's going to be from here to here. The smaller radius is from here to here, right? Now since you revolve the shaded regions about the line s equals 6, right? So your volume should be in terms of y, right? And the representative rectangles must be perpendicular to the axis of revolution, right? So, and you know that this guy is y equals square root of s, right? So in previous example, we just rewrite this one in terms of y, right? So s equals y squared, right? And the intersection right here is root 3, right? And this one is 0. Now the volume is pi times the integral from 0 to root 3, right? Now bigger radius subtract smaller radius, right? So bigger radius right here, which is s right subtract s left, right? All together square, right? Now s right is s equals 6 right here, right? So it could be 6 subtract s left, which is the curve right here, right? This one. So it's going to be s equals y squared right here, right? So subtract y squared all together square minus the smaller radius right here, right? S right subtract s left square, right? S right is 6 right here, and s left is 3 right here. This line right here, 3, right? So you have 6 subtract 3 all together square dy, right? So it's going to be pi times the integral from 0 to root 3. Now you're going to use the complete square formula to expand this one. It's going to be a minus b all together square. It's going to be a square minus 2ab plus b square, right? So it's going to be 36 minus 12y squared plus y power 4, right? Now 6 minus 3 equals 3 squared equals 9, so subtract 9. 36 subtract 9 is going to be 27, so I write 27 over here, right? dy. Then it turns out to be pi times 27y, right? Minus 4y cubed, right? Plus 1 over 5 y power 5, right? Evaluated from 0 to root 3, right? Now substitute root 3 for y. It turns out to be pi times 27 root 3 minus 4 root 3 cubed plus 1 over 5 root 3 to the 5th. Alright, so if you simplify further, it turns out to be pi times 27 root 3 minus 12 root 3 plus 9 root 3 over 5 then the final answer must be 84 root 3 times pi over 5. Now let's move on to example number 6. Find the volume of the solid formed by revolving the region bounded by the graphs y equals s squared, y equals 4s minus s squared about the x-axis. First, we need to sketch y equals s squared, right? So s equals 0, y equals 0, right? S equals 1, y equals 1. S equals 2, y equals 4, right? So it could be something like this. Now we need to sketch y equals 4s minus s squared. S equals 0, y equals 0. S equals 1, y equals 3. S equals 2, y equals 4. Alright, so if you sketch it, it's going to be something like this. Then the shaded region should be this guy. Now we need to revolve this one about the x-axis, right? So it could be y equals 0, right? And the x-axis is the axis of revolution, right? Now since you revolve these regions about the x-axis, then the representative rectangles must be perpendicular to the x-axis, right? And the volume should be in terms of x value, right? So let's get a solid. Alright, so the bigger radius is the distance from here to here, right? And the smaller radius is the distance from here to here, right? Now this one is y equals s squared, right? This one is y equals 4s minus s squared, right? So you need to find the intersection between this guy and this guy right here, right? So you need to solve a system of two equations, y equals s squared and y equals 4s minus s squared, right? Then I have s squared right here must be equal to this one right here, right? Then this guy turns out to be 2s squared minus 4s equals 0. Factor 2s out. So it could be s minus 2 equals 0. Now, this one is the 0 product, so I have 2s equals 0, s equals 0, and s minus 2 equals 0, then s equals 2, right? So the lower bound is right here, s equals 0, and the upper bound is right here, s equals 2, which is right here, right? So you have the volume is going to be pi times the interval from 0 to 2. The bigger radius square minus the smaller radius square ds, right? Now the bigger radius, which means y top subtract y bottom, right? So y top is right here, right? Y bottom is the axis of revolution, which is y equals 0 right here, right? So you have pi times the interval from 0 to 2 of 4s minus s squared subtract 0 altogether square subtract, right? Similarly, the smaller radius right here, the y top is right here, right? Y bottom is y equals 0, right? So it's going to be s squared minus 0 altogether square ds, right? So it's going to be pi times the interval from 0 to 2. Now to simplify this one, you're going to use complete square formula, right? So you have a minus b all together square equals a square minus 2ab plus b square, right? So it's going to be 16s square minus 8s cubed plus s power 4, right? And this one turns out to be negative s power 4, right? Now this guy cancel out, right? So I need to erase these two guys right here. and I put ds right here, right? So this guy turns out to be pi times 16 over 3s cubed minus 2s power 4 evaluated from 0 to 2, right? So it's going to be pi times, substitute 2 for s, it could be 8. 8 times 16, it's going to be 128 over 3 minus 16 times 2 is going to be 32, right? So it's going to be 32 pi over 3 is the final answer, right? Now let's move on to question B. Similar to question A, we're going to sketch the figure like this, and then we're going to revolve about the y-axis. So the y-axis is the axis of revolution, right? And we get the regions like this, right? So we need to find the intersection between these two guys right here, right? In the question A, you just solve s equals 0 and s equals 2, right? Now you substitute 0 for s into this equation right here to solve for y, right? So y equals 0 and then y equals 4, right? So since this one you revolve about the y-axis, your volume should be in terms of y. Alright, so keep that in mind. And your representative rectangles must be perpendicular to the axis of revolution. In other words, that is the y-axis, right? Now, we need to determine which one is the outer radius and which one is the inner radius, right? So volume is pi times the interval from 0 to 4, right? Of r y square minus little r y square dy, right? Now we need to solve these two guys right here in terms of y, right? So I'm gonna put this guy on the side. The first one, y equals s squared, right? Take square root both sides. S equals plus and minus square root of y, right? Now I'm gonna pick s equals square root of y because it's on the right of the y-axis, right? Now, I need to solve this one in terms of y, right? So I have y equals 4s minus s squared, right? So this guy is the same thing as, I'm going to multiply both sides by negative 1. So it could be s squared minus 4s equals negative y, right? I'm going to make the left-hand side as a complete square. In order to do that, I need to divide the coefficient of the middle terms by 2, and then I'm going to square, right? So I'm going to add 4. The right-hand side, I must add 4, right? Now the left-hand side becomes a complete square, so it will be s minus 2 all together square. The right-hand side is 4 minus y, right? Take square root both sides, you have s minus 2 equals plus and minus square root of 4 minus y, right? And then add 2 both sides, of s equals 2 plus and minus square root of 4 minus y, right? Now I'm going to graph these two guys right here. So I have s equals 2 plus square root of 4 minus y, and s equals 2 minus square root of 4 minus y. Y equals 4, s equals 2. Y equals 0, s equals 4, right? So s equals 2, y equals 4 is going to be right here. S equals 4, y equals 0 is going to be like this, right? Now, y equals 4, s equals 2, and y equals 0, s equals 0, right? So it could be this guy right here. Alright, So if you grab these two guys on that mode, you will see it could be something like this, right? Alright, remember the region is right here. Now, you need to pick this guy, right? Because this one right here is right here, right? So, v equals pi times the interval from 0 to 4, the bigger radius, which is the distance from here to here. And the smaller radius is the distance from here to here, right? So does that mean the parabola right here? We got it right here, right? And it's gonna be square root of y minus 0 altogether squared, right? Because the axis of revolution is the y-axis, which is s equals 0, right? S right subtract s left. S right is this guy. S left is this guy, square, right? Subtract the smaller one, which is this guy right here, right? S right is right here, right? So it will be 2 minus square root of 4 minus y all together square, right? Because you subtract 0, it's going to be this one, right? And don't forget to put the y. Now I need to simplify this one, so it turns out to be pi times the interval from 0 to 4 of y minus 2 minus square root of 4 minus y all together square dy, right? Now to calculate this one, you either calculate by hand or you can use a calculator, right? So I'm gonna use the calculator faster. So I need to hit add calculator, right? Press menu, calculus, number 3, right? The interval from 0 to 4. Don't forget pi in the front, right? Of dy, right? Hit enter. The answer is 16 pi over 3. Alright. Now let's move on to the last one. Revolving the regions about the line y equals 6. So this one is axis of revolution, right? Now we need to sketch the graph. And again, since you revolve these regions about the horizontal line, your volume should be in terms of s, right? So volume is the interval from 0 to 2 right here, right? Pi times the interval from 0 to 2. Bigger radius in terms of s square, subtract the smaller radius in terms of s square ds, right? It's going to be pi times the interval from 0 to 2. The bigger radius is the distance from here to here, right? Which is y top subtract y bottom, right? Y top is right here, y equals 6. Y bottom is this guy right here, right? So y equals s squared. So you have 6 minus s squared all together squared, right? Subtract the inner radius is going to be from here to here, right? And then it's going to be y top subtract y bottom, right? Y top is 6. Y bottom is this guy, right? So it's going to be right here. 4s, and don't forget to change the sign right here, plus s squared all together square ds, right? Now you can calculate this one by hand or you can use the calculator, right? Alright, so the interval from 0 to 2. After you input the expression, then you're going to hit enter. The answer is 64 pi over 3. And it's your time to solve. Thank you for watching. I hope you enjoyed the video. Remember that If you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.